As a premier provider of lipid excipients, GATFSA experts have developed this guideline to rationalize as well as simplify the steps taken in the design and development of SEDS. In this video, we present the key considerations and common pitfalls of SEDS developments to aid benchtop formulators in how to manage stability and manufacturability while screening formulations for bioavailability to assure that their product will be viable at later stages of development. Commonly referred to as self-microemulsifying drug delivery systems, SEDS are one of the most viable options for enhancing the oral bioavailability of poorly soluble drugs. Although the primary role of SEDS are to help solubilize drugs in the gut milieu, the presence of key lipid-based excipients is necessary to facilitate an API's permeability across epithelial cells and can favor its absorption via hepatic or lymphatic routes. As such, SEDS can provide optimized pharmacokinetic parameters and minimal variability to produce desired therapeutic outcomes. To better understand SEDS, let's begin with the concept of self-emulsification, being, that is, the instant dispersion into fine droplets of an oil and surfactant system in aqueous gastric media without the need for heat or mechanical energy. Seen under microscope, here is a small droplet of Laborfil 2125CS, an excipient with autoemulsification properties as it comes into contact with water. The Laborfil droplet instantly swells as it absorbs the surrounding water into its core, and through the formation of pores, it breaks down into smaller submicron droplets being released into the surrounding aqueous environment. For autoemulsification to occur, the drug delivery system must consist of the appropriate quantities of three key components: a lipidic oily vehicle, a surfactant, and a co-surfactant, areas of unique expertise at GATFSA. Simply put, Laborfil M2125 has been developed to contain all the necessary components, making it a ready-to-use SEDS, and all that is left for the formulator to do is to test the solubility of the API in it at the desired dose. Other autoemulsifying excipient series developed by GATFSA with varying physical, chemical, and biopharmaceutical properties are Gelusir 4414, Gelusir 5013, and Labrosol ALF. With precedents of use in globally approved medicines, these excipients are routinely screened for solubility and compatibility with various drugs for direct filling into soft gel or hard shell two-piece capsules. In the case of APIs that do not have sufficient solubility in a single self-emulsifying excipient, and especially when the objective is to modulate the pharmacokinetics of drug absorption, formulators may opt for a tailored approach to address the unique set of challenges presented by the drug at hand. To this effect, GATFSA has developed a range of excipients to help formulators dial in the perfect SEDS system for their drug. A customized approach to SEDS development therefore begins with a thorough screening of the drug solubility in an array of oils, surfactants, co-solvents, and co-surfactants. Here are some key considerations in the SEDS development process. As shown, the first step is to determine the API solubility limits in individual excipients in order to select the best possible vehicle or vehicle combinations based on the required dose and type of dosage form. An equally crucial consideration at the screening step is the biopharmaceutical role, that is, the potential impact of the excipient chemistry on the permeation and subsequent absorption of the API. In scenario A, where a single excipient provides sufficient solubility for the API in question, the formulator can proceed to step 3, lipolysis testing, in order to determine the ability of the formulation to maintain API solubility in lipid digestion media. In the next scenario, where two or more excipients need to be combined to achieve a certain drug load or to influence the drug pharmacokinetics, it is crucial to verify the miscibility of the selected excipients at targeted ratios. Miscibility of liquids is typically assessed 24 hours after the preparation is allowed to rest at ambient temperature by a visual inspection, looking for any phase separation or precipitation of the API. In the case of solid excipients, miscibility and compatibility may be verified by thermal analysis monitoring. Regardless, this step is necessary for optimization of the eventual formulation while eliminating risks of incompatibility-related failure downstream. Once the basic makeup of the formulation is determined, In vitro lipolysis testing is carried out to assess the formulation performance upon dilution in the presence of lipolytic enzymes. The ideal SEDS will maintain 75% of the dose in solution for a period of 60 minutes. In practice, however, lipolysis testing is an in vitro tool for narrowing down the number of prototypes destined for in vivo studies. While performing these basic screening steps, it is important to strike a balance between formulation bioavailability, stability, and manufacturability. In this next section, we will go over some helpful do's and don'ts while optimizing the screening and development process for a SEDS formulation. Let's start with a list of recommendations as they apply to the crucial steps of screening excipients for solubility and bioavailability. At the solubility screening phase, it is crucial to evaluate API solubility in as many types of excipients as possible. Having an early, thorough understanding of the API solubility in a wide range of excipients can save you time down the road, so don't limit selection of excipients to liquids only. Saturation solubility in liquid vehicles can be determined by equilibrating the API at room temperature and assayed by high-performance liquid chromatography. As for solid lipid vehicles, the API must be added into the molten excipient. The mixture is then allowed to rest and resolidify for at least 24 hours before analysis by differential scanning calorimetry or hot stage microscopy. Achieving the equilibrium concentration at ambient temperature helps mitigate the effect of temperature-related or kinetic solubility. GATT-Visay has ready to share procedures that can be made available per request. Simply ask us. When screening solid vehicles that require melting before adding the API, do assess the stability of API at elevated temperatures. It is not recommended to select a drug load above 80% of saturation concentration to avoid nearing the saturation point. Although a supersaturated solution may be beneficial in terms of bioavailability enhancement, supersaturation can also jeopardize the formulation's physical stability, leading to potential API crystallization during the product's shelf life. The conventional dissolution testing and particle dispersion size determination are important steps in the characterization of SEDS formulations. For better in vitro in vivo correlation, however, consider dissolution testing in biorelevant media, such as lipolysis testing, to identify formulations with better in vivo performance. Significant bioavailability enhancement is achievable only if the API is solubilized in one or more of the SEDS components. If your API is merely dispersed and not solubilized in the SEDS, it may precipitate out upon gastrointestinal dilution. As a result, the API will not be able to participate in the lipolysis process, maintaining solubility in the lipid vehicle as previously described. Lymphatic uptake, which helps bypass pre-system elimination, is exploitable only for API that have high log-Ps and which have high solubility in long-chain glycerides. Therefore, in order to promote lymphatic absorption, the SEDS formulation must consist of excipients containing long-chain fatty acids like oleate or linoleate. Here are some considerations relative to stability, manufacturability, and scale-up at further stages of development. Do be sure to consult the handling instructions for each excipient before use. Lipid vehicles should be stored under nitrogen to preserve excipient quality and stability. Self-emulsifying excipients can absorb moisture, so avoid high humidity and heating with water baths. Semi-solid block form excipients, such as Gelucir 4414, must be fully melted and homogenized before sampling, rather than scooped from the top. If you have any questions about the handling protocol for any GATT-Visay product, please do not hesitate to contact us. To avoid unnecessary introduction of oxygen to the formulation during the mixing process, it may also be necessary to apply vacuum during the process. Additionally, consider adding antioxidants when working with sensitive API or excipients. As with any other formulation, API excipient compatibility studies are a key component of SEDS formulation screening. Subsequently, capsule shell compatibility can be assessed by consulting both the excipient and capsule suppliers. GATT-Visay provides capsule compatibility information for all of our excipients. Two-piece capsules may be viable for early-stage, small-scale development of liquid SEDS formulations, but for large-scale and commercial manufacturing, it will require an additional banding step. Soft gels are more suitable for large-scale manufacturing of SEDS because they do not require the extra banding step to prevent leakage of liquid-filled two-piece capsules. Lastly, a thermoreogram is used to determine the optimal capsule fill temperature and consistency profiles of semi-solid formulations. This is accomplished by a plot of formulation viscosity as a function of temperature as it is allowed to cool down. The optimal filling, i.e. the lowest possible filling temperature of a semi-solid formulation, is typically set to 5 degrees above its solidification point. To summarize, in this video, we have shared the key considerations and common pitfalls of SEDS development based on decades of work by GATFSA experts. Applying these unique guidelines to our excipients makes it possible to simultaneously address manufacturability and stability while optimizing solubility and bioavailability. Our aim is to aid benchtop formulators in tackling multiple objectives in a series of steps to assure that their eventual SEDS formulation will be viable at later stages of development. Thank you for tuning in. If you have any questions about your specific formulation, or you would like to learn more about how GATFSA can help assist you in developing your SEDS product, please reach us via LinkedIn, visit our website at www.gatfsa.com, or email us directly at info@gatfsacorp.com.